Alright, question 6. Find the range of values of q for which the equation qx squared plus 2 equals x bracket x plus 3 does not cut the x-axis. So does not cut the x-axis means the quadratic curve is either totally above the x-axis or totally below the x-axis. So it's a situation where you have this or a situation where you have that. Alright, in any case, there will be no real roots, right? So we first simplify the equation. Qx squared plus 2 equal x into 3 plus x. Simplify this, I will get 3x plus x squared. Bring it over, I will have qx squared minus x squared minus 3x plus 2 equals to 0. Factorizing out your x squared, I will have q minus 1 x squared plus 3x minus 3x plus 2 equals to 0. So since the curve does not, since the discriminant, since there are no real roots, right? Because the curve doesn't cut the x-axis, so discriminant is less than 0. So b squared minus 4ac less than 0. Your b is negative 3, a is q minus 1, and c is 2. So I will have 9 minus, bring it together, 8, q minus 1 less than 0. So 9 minus 8q plus 8 less than 0. So 17 minus 8q less than 0. I will have 8q bigger than 17. The q is bigger than 17 over 8. Alright. So that is the condition. Now you notice that there are two situations here. Either the curve can be U-shaped or inverted U-shaped. So in this case, we have got the answer q is bigger than 17 over 8. Obviously, you are referring to this case. So q must be bigger than 17 over 8, and that 17 over 8 is actually bigger than 0. So we don't have to worry, right? Because for this case, your q must be bigger than 0. For this case, your q must be less than 0. For this case, q must be bigger than 0. So this case doesn't apply because your q is bigger than 17 over 8.